class, today our new lesson is about exponential equations. Exponential equations, as you see the definition of this on the screen, are the equations which the unknowns can be appeared as exponent, not as base. For example, 3 to the power of x plus 2 is equal to 1 is an exponential equation. However, x times 3 to the power of x is equal to 2 is not an exponential equation. And the solution of exponential equations is the set of all those values which are true for this equation or which satisfy this equation. We have different types of exponential equations. Today we'll study some of them. The first one, equations in the form a to the power of f of x is equal to a to the power of g of x, where a is positive and a is not equal to 1. Why? Because if a is equal to 1, so 1 to the power of 2 will be equal to 1 to the power of 5. Both of them are equal. But according to these types of exponential equations, if the bases are equal to each other, so the powers are also equal. So 2 must be also equal to 5, which this one is not true. So therefore, we say that a or base cannot be 1. As we know that exponential functions are one-to-one functions, so a to the power of f of x is equal to a to the power of g of x. In here, if bases are equal to each other, so the exponents must be also equal to each other. Or the equation of exponents is at the same time satisfy the equation itself. It means that a to the power of f of x is equal to a to the power of g of x. For example, let's solve some examples about these types of exponential equations. 7 to the power of x plus 9 is equal to 7 to the power of 2x minus 15. Let's solve it. As we say that exponential equations are one-to-one, so if bases are equal to each other, so powers or exponents must be also equal to each other. So in here, x plus 9 must be equal to 2x minus 15. It's simple, a linear equation. We can solve it. We can subtract x from both sides and add 15 to both sides to take unknowns to one side and constants to another side. In here, x and x will be cancelled, and negative 15 and positive 15 will be cancelled. 2x minus 1x is equal to 1x is equal to 9 plus 15 is 24. So the value or the solution set for this equation, x is equal to 24. Next one, 3 over 11 to the power of 3x minus 10 is equal to 11 over 3 to the power of 7x minus 11. In here, the bases appears as unequal to each other, but we can equalize them, these two bases. How? 3 over 11 is equal to 11 over 3 to the power of negative 1. It means we can make this negative 3 over 11 over 3 as 3 over, we can write it as 3 over 11 to the power of negative 1. So rewrite the equation. 3 over 11 to the power of 3x minus 10 is equal to 3 over 11 to the power of negative 1 completely to the power of 7x minus 10. So let's rewrite again. Let's simplify power by power. 3 over 11 to the power of 3x minus 10 is equal to 3 over 11 to the power of negative 7x plus 10. Let's continue. As bases in here are equal to each other, so the powers or the exponents are also equal to each other. So 3x minus 11 is equal to negative 7x plus 10. It's also a simple linear equation. We can add 7x to both sides, and we can add 10 to both sides. 7x plus 10. In here, 7x and positive 7x and negative 7x are cancelled, and negative 10 and positive 10 is cancelled. 7x plus 3x is 10x, and it's equal to 10 plus 10 is 20. If we divide both sides by 10, we will get x as equal to 2. Okay, let's solve another example. The third one, as you see in the screen, 5 to the power of x plus 2 times 2 to the power of x is equal to 10 to the power of 4x minus 1 over 4. As you see, this example doesn't have the form of a to the power of f of x is equal to a to the power of g of x. But we can give it this form. How? Let's solve it. 5 to the power of x plus 2 times 2 to the power of x is equal to 10 to the power of 4x minus 1 over 4. We can write this 4 as 2 to the power of 2. Again, rewrite it 5 to the power of x plus 2 times 2 to the power of x is equal to 10 to the power of 4x minus 1 over 4. Or 2 to the power of 2. So let's multiply both sides by 2 to the power of 2. 5 to the power of x plus 2 times 2 to the power of x times 2 to the power of 2 is equal to 10 to the power of 4x minus 1. As you see in here, 2 to the power of x times 2 to the power of 2 will become times 2 to the power of x plus 2 is equal to, again, 10 to the power of 4x minus 1. As we have same exponents in here, x plus 2 to left side, so we can multiply bases. 5 times 2 to the power of x plus 2 is equal to 10 to the power of 4x minus 1. So 5 times 2 is 10 to the power of x plus 2, and it's equal to 10 to the power of 4x minus 1. It has the format of a to the power of f of x is equal to a to the power of g of x. So bases are same, powers are also, exponents are also equal to each other. So x plus 2 will be equal to 4x minus 1. So let's take the variables to unknowns to one side and constant to another side because it's a linear equation. So negative x plus 1. We add negative x plus 1 to both sides. Negative x plus 1. As you see that negative x and positive x will be cancelled. Negative 1 and positive 1 will be cancelled. So in here 4x minus 1x 3x is equal to 2 plus 1 3. As if we divide both sides by 3, so x will be equal to 1. For these types of exponential equation, check yourself routine is your homework in your math books. If you have any question, you can contact us to our school phone and you can send your questions by WhatsApp number of the school phone, and I will respond you. Thank you. And the second type of exponential equation is the exponential equation of the form a to the power of f of x is equal to b, where a is positive and a is again not equal to 1. In here, if b is 0 or a negative number, or b is less than or equal to 0, so it has no solution because exponential equations must always be positive because a is positive, base is positive. But if b is a positive number, so in this case we write this exponential equation into logarithmic form, which f of x is equal to logarithm of b to the power of a, and then we solve it for x. Let's solve an example about this. For example, 3 to the power of x plus 1 is equal to 4. The question asks us to solve it for x. It means find the value of x. So 3 to the power of x minus 1 is equal to 4. From here we can write it in logarithmic form, which is x minus 1 is equal to logarithm of 4 to the base of 3. If we add 1 to both sides, so negative 1 and positive 1 will be cancelled. X is equal to logarithm of 4 to the power base of 3 plus 1. We can continue after this. We can write 1 as logarithm of 3 to base 3. So x is equal to logarithm of 4 to base 3 plus logarithm of 3 to base 3. By using the properties of logarithm, we can write this addition, or we can change the addition to multiplication like this: logarithm of 4 times 3 to base 3, which is equal to logarithm of 12 to base 3. So x is equal to logarithm of 12 to base 3 is the answer. Next example, as you see in the screen in here, 2 to the power of x squared is equal to 3. So we use the same method in here. X squared is equal to logarithm of 3 to base 2. If we want to find x, so we should take square root of both sides. So x will be equal to positive negative, because it has two different values, positive and negative. Square root of logarithm 3 to base 2 will be the value of, or the values of x. Next example, as you see in here, 5 to the power of absolute value of x plus 2 minus x plus 1 minus 2 is equal to 1. Again, we use the same method. Logarithm or absolute value of x plus 1 minus 2 is equal to logarithm of 1 to base 5. We know that logarithm of 1 to any base is equal to 0, so absolute value of x plus 1 minus 2 is equal to 0. So we add 2 to both sides. Some mathematics teachers they say that we carry negative 2 to the other side. No, in fact, we are not carrying negative 2 to the other side. It's not true according to mathematics. We are adding 2 to both sides. The negative 2 and positive 2 will be eliminated. In this case, x plus 1, absolute value of x plus 1 will be left. In here, 0 plus 2 is equal to 2. As you take 2 in this side, or if you, as you get 2 in this side, you think that we carry negative 2 to other side. No, in fact, we are adding 2 to both sides. Okay, if absolute value of x plus 1 is equal to 2, so x plus 1 is equal to 2. It has two different values. And x plus 1 can be equal to negative 2 also. If x plus 1 is equal to 2, so in this case, x will be equal to 1. If x plus 1 is equal to negative 2, so in this case, x will be equal to negative 3. Yeah, the fourth example, as you see in here, 3 to the power of 2x minus 3 is equal to negative 1. We study that, or we say that if b is less than or equal to 0, it means if it's negative, so it has no solution. So in this case, this example or this problem, 3 to the power of 2x minus 3 is equal to negative 1, has no solution. Check yourself 15 in your math books as your homework. Again, if you have any problem, you can ask us from WhatsApp number of the school and we will respond you. Thank you.